So hello everyone. This is day 13 of building our own decks. I'm building my own decks, right? So let's just continue our work. Yesterday I built a contract for faucet, and today is the day in which I will be building the part of our decks, that is the liquidity pool smart contract, right? Now, what do we need in this liquidity pool smart contract? We need a LP token. Right now, what is this LP token? Now, just LP tokens are nothing that they are just tokens like our token X and token Y, but they are used for representing the share of the liquidity provider in our pool, right? It is that simple. And this liquidity tokens are being minted and burned, uh, commensurated to the amount of the tokens provided by the liquidity provider, right? So this is what LP token does. Okay. So yeah. So let's just build this LP token in our pool contract and just write the simple smart contract for the liquidity pool, right? So let's just go here. So let's just write the code for liquidity pool, right? So first, what we need is a license identifier. So DEX, then pragma, solidity, version is 2.8. Then what we need is a contract, right? For liquidity pool. So I'll import this. I don't need Pwnable as of now. Then let's write a contract for LP token, LP token that is ERC20, right? Now what we need is a constructor that's ERC20, right? Uh, I'll write LP token. And this now over here you have to just give the symbol that is LP, right? And yeah, it's like this. Okay. The constructor is empty. Okay. Now what we need is a function to set the pool. So function set pool, right? Now what does this do? It sets the pool address, right? So yeah, like this and like this. Okay. What am I getting over here? Uh, okay. Okay, so first over here we need to initialize this pool. So it will be address public pool. Okay, address public pool. Yeah, so now what does this function do? This function is actually setting up the pool, and only the owner of this contract can do this, right? Yeah. So only pool can set the liquidity pool smart contracts address can only set this pool, right? Then what we need is a function. Now let's make a modifier, right? So modifier. Uh, what does this modifier do? This modifier is actually checking that that is this contract being called using the pool's address, right? So yeah, this is what this modifier is doing, right? Then what we need is a function to mint the LP tokens, right? Then here it is address. Yeah, So yeah, this is a simple mint function, right? Then what we need is a burn function, function burn, right? So yeah, this is pretty much it for our LP tokens smart contract. Now what we need is a contract for liquidity pool, right? Yeah, so now what we need is a contract for liquidity pool. So contract liquidity pool, right? Contract liquidity pool. Now it gave me everything, but we won't be taking this. Now, what functions do we need in our liquidity pool, right? So first we will be needing a function to update the reserves. So function, first we will be needed a function to add liquidity, right? So for that, we need to actually initialize all the variables, right? So first we'll be initializing the variable as public token X, then the address of token Y, right? And then the address of LP token, right? Now what we need is actually the track of the reserves of the token X and token Y. So that will be uint 256 and public public reserve public reserve X, yeah, RECRV reserve X, right? And uint public reserve Y, right? And now what we need is a fee, right? Whenever any transaction will be done, like if any user is swapping token X or token Y, right? There will be a fee for it, right? So that's UN 256 public. Let's just do it constant. Fee is 3, right? So it deducts 0.3% of fees, right? Now what we need is a constructor. Yeah, let me just check. Token X and token Y, LP token. No, no, not like this. Let's take the address of token X and token Y, right? Then we'll be taking the address of LP token as well, right? And then over here, LP token equals to this LP token and the address that is LP token. This is the correct way to do that. Yeah. Hmm. So we have built constructor over here, right? I mentioned address over here, but we have to make a LP token, right? So we have to make the instance out of it, and I just use that over here. Okay. So now what we need is actually setting the LP token to provide 1, 2, 3, 1, 2, 3 start. Oh, so sorry. I just what did I wrote over here? I wrote address over here, right? But we have to actually initialize it with LP token, right? So yeah, this is the variable which is storing the LP token. So I got this over here. Now what I need is to set the pool using the LP tokens address. Yeah, so this is our constructor, right? Now, what we need is to add the liquidity to the pool, right? So let's just write a function, add liquidity, right? Now, what does this add liquidity function takes into the parameter? So it's un 256 amount of x, un 256 amount of y. What is it telling? It's correct actually. And external in this. Okay, for UN 256. Okay, this is our function definition. Now, what we need is require case require, and it checks the amount x should be greater than 0, right? And amount y should also be 0. And if it should also be greater than 0, and if it is not, this is amount x. And if it is not, it will just return amount must be greater than 0. Let's this actually Control X and Control V. AMMount, right? Okay, so this is it for the add liquidity function. We have added a require case over here, right? Now what we need is IERC 20 token X should be transferred from message.sender to address dot this means the address of this liquidity smart contract, right? And what's the amount? The amount is this amount X. Then I need ERC, just a second. Okay, so we have built the constructor now, right? Now, what functions do we need over here? We need a function to update the reserves, which will be taking a UN256. UN256, no, it won't be taking any parameter, right? It will be a private function, right? Then it will be just updating the reserves, right? Then what we will be needed is a function to add liquidity
add liquidity, okay, which will be a external function, right? Then we need a function to remove the liquidity, remove the liquidity. Then what we need is a function to actually swap x for y, x to y, right? Which will also be an external function, right? And then we need a function to swap y to x, right? That is also external function. Then we need a function to get reserves, but we will also be needing a function to calculate the square root as well, which is a very important thing. Function sqrt square root, right? Actually, yeah, let's just take this. Yeah, the square root function, right? Which is doing nothing but just calculating the square root, right? And then we will be needing a function to find minimum. Function min, yeah, which takes two parameter and finds minimum. Right, so we have our skeleton for the liquidity pools contract ready, right? Now let's just write a function to add the liquidity, right? Okay, so let's write, okay, so one, two, three, start add liquidity. So let's write a function to add the liquidity, right? So for that, we need a parameters of uint amount, uint 256, amount, the actual amount of X which the user wants to deposit into our liquidity pool. So that will go here, right? Amount X and uint 256 amount Y goes here, right? This is an external function. Now what we need is to check that that if the value of the amount x and amount y is 0, it must return that the amount should always be greater than 0, right? So for that we'll be using require. In conditions we will be writing amount x should be greater than 0, and then amount y should always be greater than 0, or else the amounts must be greater than 0 will be the message, right? What's the problem? Yeah, the thing. Function state. Okay, no problem. Now from here we need a IERC20, right? Token. What's our token name? It's token X. Now the amount of amount the amount mentioned over here will be transferred to this pool's address, right? Which is message.sender, right? No, which is address.this. So the amount X will be transferred from this address to this address, right? Similarly, we'll do this for Y as well. So amount of Y will be transferred from this address to the address of this pool's address, right? Now, yeah, this is done. Now we need a variable called liquidity, right? Then we need a variable to keep a track of this supply, right? So this will give us the total supply of the LP token, right? Now here comes the interesting part, right? Now, what if there is zero token X and token Y in the pool, right? So let's just go to Excel draw. Now, let's suppose that the pool is empty, right? So how much will be the supply of LP tokens, right? Now let's take an example that the user is depositing, the liquidity provider is depositing token X and token Y into the empty pool, right? Now, how much will be the supply of LP token? We don't know the supply of LP tokens, right? So now what will be happening is this will, we have to just multiply this 4000 with 100 and we'll find the square root of it. So what's the square root of this? The square root of this is 2000. No, not 2000 actually. Yeah, 2000. Okay. 20,000 and 2000. Okay. So yeah, then 20,000, the 2000 LP tokens are minted onto the address, right? So what just happened? We find the square root and now this number becomes the total supply of LP token, right? Which are minted onto the address of the liquidity provider, right? So that's why we wrote a function to find the square root. Okay. So yeah, let's just continue with writing our add liquidity. Okay, so if say total supply equals to 0, then liquidity equals to square root of amount of x and amount of y. Yeah, perfect. Yeah. Now we need is else case. Else what will happen? Else we will be finding the minimum. So liquidity liquidity equals to minimum. mm, yeah, let's just write it clearly over here. That is using this. What just happened? Yeah. Okay. So this is how it is done. Now, why are we finding this minimum? Right? Now, if a case happens, let's say that a user, now the ratio of the pool is actually 1000 and 4000. So here that let's say total supply is 2000, right? Now, if the user deposits X equals to 2000 and y equals to 7000, right? Now this is not maintaining the ratio of this pool. Then what will be happening is we will be actually calculating this using amount of x. So that is 2000 into the total supply. So what is the total supply? The total supply is 2000, right? And we'll divide it by the reserves of x. So now what will be the reserve of x? The reserve of x was 1000 over here. Yes. Okay. So yeah, this is the case. Let's just check it once. Okay. So yeah. So the answer will be 4000, right? Yeah. Now, similarly for Y, the total supply Y is 7,000 into what's the total supply of Y? Total supply of liquidity, right? Total supply of liquidity divided by the Y, right? So let's just calculate this. This is 7,000 into 2 divided by 4. So let's go to calculator. 7,000 into 2 divided by 4. So this gives 3500, right? Where is that? Okay. So this is 3500. Okay. Now we get two values, right? That is 4,000 and 3,500. Now what's the minimum of this two, right? The minimum of this two is 3,500, right? So now the total supply will be equals to 3,500, right? So this is why we wrote the minimum function, and this is what is happening over here, right? So now what we need is require liquidity to be greater than zero, or else it will be returned liquidity must be greater than zero or insufficient liquidity, right? And then LP tokens will be minted to the wallet address of the user, the liquidity provider, right? And then the reserves will get updated, right? So yeah, this is a function to add the liquidity. Now we will be writing a function for removing the liquidity, right? So for this, we will be taking u and the amount. What will the user will withdraw? They will withdraw the LP tokens, right? So LP amount, it's an external function, right? Then it is required LP amount is greater than zero. The amount must be greater than zero. Yeah. Then you and the total supply of the token, right? Now, how much token X will they get? They will get token X corresponding to the liquidity amount or the liquidity they hold, right? And amount Y, right? And now over here, the tokens will actually get burned. So LP token dot burn, right? And yeah, this case, okay. Mhm. So will get burned. Now what we need is IERC 20. Now we need to actually transfer the tokens as well, right? So token X dot transfer and message dot sender to amount X, and then token Y also, and we'll update the reserves as well, right? So yeah, we should remove this line. Okay, so we have written the remove liquidity function as well, right? Now what we need to write is a function to actually swap, right? 1, 2, 3. Now what? 1, 2. restart. Now what we need is a function to actually swap x from y, x to y, sorry. So yeah, over here I need amount unit amount of x, the amount of x which I need to swap, right? Then require amount amount of x should be greater than 0, and amount must be greater than 0 will be the response, right? And then I need the token x, so IRC token x dot transfer, token x will get transferred, right? And IERC20. Okay. Now the question arises that how much amount of token Y will the user be getting? So that will be done using u and amount of Y, right, equals to amount of x with fee, right? So we first have to calculate the amount with fees, the amount of Y with fees, right? So un amount with fee equals to amount x into 1000 minus fees. So this is 3% of fees, 0.3% of fees, right? And then what we need is amount of y, and then the required case, right? And yeah, now I need IRC20 token y. Now the token y also gets transferred. The amount is amount y, and this will update the result, right? Yeah, okay. So this is done. Now what we need is a function to actually swap y to x, right? So this is pretty much similar to the above function, right? So we'll need a require. First we need a amount over here, and amount of y, right? Then the required will have amount of y equals to 0, then token of y. Now we need to calculate the fees as well, amount with fees, right? Then unit amount x, we'll calculate amount x. Mm, yeah, it's correct. Then we'll transfer the total amount of y tokens. So this and this, and we'll update the results as well, right? So we have written a function for swapping y to x. Now we also need a function to get reserves. Okay, so yeah, this is pretty much it for the liquidity pool smart contract, right? Now what we need is to actually write the test case for this pool smart contract, right? So I have the tests written over in. Okay, so let's go and get the test case file for this. I won't be writing test right now, just to save the time in the video. Um, I had my chat over here. I just say to give me the test script. Give me the test script for this. Uh, give logs as well. Okay, so we got the test script. So let's just copy this and I'll paste it over here, right? Now what we will do is run this test script. So npx hard hat test, right? So yeah, it ran all the test cases for me. Now what is this test file doing? Let me explain you quickly, right? So it is just initializing the variable that is token for token X and token Y and then token the LP token, right? Onto this addresses, onto this variable, the address of the tokens will be stored, right? Then we are having a before each case in which we are connecting all the contracts and deploying them, right? Yeah. So it is deploying the liquidity pool, right? Okay. Now what we are having is a it case for adding the liquidity, right? So it's over here. Yeah. So what it does is it approves the transaction, right? And adds initial liquidity of 100 and 200 tokens of X and Y, right? And it updates the balance of LP token. Then, yeah, this is the important one, right? If the if the user is actually, let's just get a brief overview using a skelly draw, right? So first there is a pool, right? In that the user provides 100x and 200 of y. Yes, 100 of x and 200 of y, right? Now what happens? The user needs to swap, let's say 10x, right? So now what is the second state of the pool? The second state of the pool becomes 110x, right? And now for this, we need to find the value of y. So that will be x into y equals to k. What was our k? K is 2000, right? So y will actually be equal to 2000 divided by 110. So what is 2000 divided by 110? Yeah. So 2000 divided by 110. So this gives us this, right? 18.181. The amount is 18.132 of y. This 18.13 amount of y on swapping token X, right? So yeah, this was the video for writing liquidity smart pool liquidity. So what just happened over here? we got 18.312 amount of Y on swapping token X when the liquidity pool was filled with 100 tokens of X and 200 token of Y. So the K was 2000, right? So we got the 18.13 tokens of Y on swapping 10 tokens of X, right? So yeah, this was the video for today, right? So let's just uh, keep this till over here, and I'll see you tomorrow. Thank you.